Okay, so we are going to do a quick, a small competition of sorts, if you will. This is the data set that I had discussed with you guys a couple of weeks back. This was from week 2. So if you look under data sets, for week 2 data sets, there are 3 sets of data we discussed, if you recall. One was home prices, one was retirement investment, and third was bank salaries. Okay, so this is the bank salaries data. So um, this is an interesting data set just because it has so many variables that can be built as categorical variables, and you can slice and dice the data into multiple different directions. Okay, so I'll have 5 teams. Okay, and each team has 4 members, right? So your job is, first and foremost, to put this data set as a team into Tableau. Okay, understand, we talked about this in the past, that um, because they're all numerical data, Tableau puts all of them as measurables, right? But whether they're dimensions or not, it is up to you to define that. Okay, so as an example, gender, male, female, they'll put that as dimensions. PC job, no, yes, they'll put that as dimensions by default. But for all the others, Tableau doesn't have to define that as a dimension. A dimension is essentially a categorical site. So you may have to pull that data variable or that column of variable as a dimension as you eventually open up the data set. Okay, so as you study this data and as you review the discussion that we had from that class on how we looked into the conceptual model of the data and stuff. So because you are 4 group members, um, decide among yourselves 4 core areas that you would want to visualize from this data set. Okay, each one team member take responsibility for one of those core areas, and then each one of them design that um, specific area in Tableau in terms of how you would want to represent that data. It doesn't have to be absolutely out of the park understanding. A very simple setup in terms of, and don't do this, but I'm just giving an example. Do males and females differ in terms of bank salaries? That can be a very basic question that you are trying to answer. And that could be just plugging in that data, putting that into some form of a graph in Tableau, and then that becomes one piece of the puzzle. And again, I already said that, so you have to do something different. So you can do multiple groupings, filter by many other things. You can do groupings by something else for salary, and then filter that by gender, and do all kinds of 9 yards depending on what you are trying to see. So my first question to you is, as a as a team, um, your first job is to come up with those 4 key questions that you would want answered, 4 key areas that will help you or somebody make decisions based off of this data. And so then each one of you can pick up one of those areas and start um, using Tableau, because you have already come through an assignment. You kind of have an idea of where some of these basic analysis can be done, and then let's combine all of those into a dashboard, and let's see how the team responds to the data set, and I'll see which team does the best job here. Okay, so that's kind of the deal. I'll give you um, the rest of this session to work on it, and of course I'll be traveling between each teams periodically to check on what things are going on. But what we will do is from now till, let's say, the next um, 40 minutes, okay, um, we'll have time to work on this together as a team, um, and once you are done, we will come back in the final session and have each team present. Your presentation should not last more than 5 minutes. Okay, so on what kind of a dashboard you can look at, what kind of answers are you seeking, and how the data feels. Okay, so that's basically the job here. I'm going to. Okay, let's start with team one. And so would somebody on team one take the initiative and make a presentation?
Amy, do you think you can share your screen?
Yes, I was just gonna say I couldn't remember if we were group one or not.
Oh.
Yes, and I can help you with that. Yes, team one was Amy, Matt Putman, Nick, Noah, and Sarah Alzara.
So these are the questions that we kind of wanted to visualize data with, or to answer. We actually did only 2 of these. One being how does education level impact salary? And the second was the second one, we actually combined, we did a measure that combined both years of experience. So year one, which was it year one that was how many years inside the firm? Yes, inside the bank. And then year two, which was previous to them working at the bank. And so we combined both and just called it combined years of experience. And so, Amy, do you want to highlight any of these graphs or talk about them a little bit?
Can you see them big enough?
Can you make it a slideshow from the current slide? Yep.
Okay. So something interesting we noticed in the education is that at the bottom you can see that education group 1, which was just graduated high school, actually has some higher salaries than graduating college.
Well, number 2 was some college courses.
Oh, some college. Okay.
Yeah.
But it's interesting that they flipped positions there.
Yeah, and so that's a very nice point. So that basically tells you that probably there is something, quite a few other things beyond just the education, based off of the time when the data was collected, that was drawing salaries. So many people got into the banking sector in the old days straight from high school and started building from scratch and growing up the ladder. And so for many of them, it's highly possible that they may have a level 1 education, but they have many more years of experience, which has jacked up the salaries compared to the level 2. So that's probably one way of trying to explain that story.
So this is just a screenshot of Tableaus, but so I can't do it in here. I mean, I do have the Tableau open.
Yep.
But we had a filter for male and female there as well.
Yeah, if you want to present from Tableau, that's fine too. Just share your screen from choosing the specific Tableau. Yep.
So we have this male and female filter.
And so what's the storyline here?
So if you click both, you could tell, so the legend says that the orange scatter plot is the females and the blue is the males. And Dr. B helped us observe that the linear trend of the males takes a much higher, like it's a much higher line. So like the older or the more years of experience that a man could have, they are compensated for those years of experience, like accordingly, whereas women kind of tend to, it's a more of a flat line. So it shows you that it doesn't matter. Well, at some point, those extra years of experience are not, she's not compensated as much for. And so that's kind of what the storyline there tells you.
Nice. And given the context, I think that's where you had stopped. You just looked into these you were able to look into these two options, right?
Yes.
Yes.
And then let's hear from some of the other teams and see, you know, if they have gone into some other directions, and we'll kind of summarize at the end. So team two had let's say Ashley, Brandon, Nathan, and Sarah Shikora.
Yes, okay, let me share my screen. Oh. So these were the four questions we were hoping to answer. How does the level of education affect their salary? How does age affect salary? Does having a PC-based job contribute to a higher salary? And how does your level of experience affect salary?
Stop there for a second, Sarah. Go back.
Oh,
so
yes.
As you guys can see that this team has actually used the story option in Tableau, which is an internal Tableau built-in option to present your work. And if you recall from Nick Barton's presentation, he had specifically mentioned this at the end of the presentation. I'm happy to see at least one team has actually applied that in the context of presentation. So go ahead.
So yes, this first one we have here is salary by experience, and it's actually broken down. So I should have relabeled it, but years one down here is years of experience in this particular bank. And then we've got also a heat map going. So you can see over here, green is 0 years of experience in an outside bank, outside banking institution, and going up to orange and red is more years. And so we can see that, yes, there is a definite trend towards more years of experience in that particular bank, leading to a higher salary. But you don't actually really see much of a trend of number of years of outside experience leading to a higher salary. Because you see most of the orange and yellow dots are here in this cluster and not up here. Who wants to go next?
So for salary by age, what we did, we took the average salary combined between both male and female and graphed this along this line you're seeing. And this shows that as the age of an employee increases, the salary typically increases until you get to this part towards the end, right around age 61, to where there's a tremendous drop off. And of course, the data is there if you wanted to explore that and figure out a conclusion as to why that occurred. You could do that, but what we've done is just map out how the average salary correlates with the age.
So one thing I want to also mention, and this is for all the teams, as you are talking about these visualization reporting processes, understand that a statistical technique has not been used yet. Okay, so when you are inferring, you are not really inferring at this point. All you can say is the data suggests that perhaps XYZ is happening, as opposed to inferring with confidence. That's a different story. So if I go back to the previous team's analysis, so they were looking at their scatter plot in terms of how males and females differ in their salaries, right? And if you recall the scatter plot, you'll notice that there is quite a level of difference in terms of male versus female salaries. But you can't conclude that males get paid more just based off of that. All you could say is this data set seems to suggest that the salaries for males are higher, especially with higher experience that seem to go higher. Whether it happened by chance or statistically you can say whether it's higher or not is what you will learn for the rest of this class. Okay, so that's where the statistical tests come in. So if you have taken a course in statistics in undergraduate, you recall probably the z-tests, the t-tests, the ANOVAs, the regression, all that will come to eventually provide that inference. This is a smell test. This is an initial overview of how the data seems to behave. It doesn't give you the end result. It doesn't tell you the actual answer. It doesn't infer. It just tells you which way the data seems to behave. So always keep that in mind when you're talking about visualization of data. Go ahead.
So for the next graph, which is below the salary by age, we were looking into seeing if having a PC skill set would increase in salary. And so what the data infers is that it's not really giving you an increase of salary if you have that PC job. So we also did it by age too. As you could see, a lot of the PC jobs are actually shown in between the 30 and to 45 range, but they still have an average salary around 40, 45, which you still have employees who are older who are making more money still. So
That's still so. And when you are an older employee with a lot of experience, it doesn't seem to matter whether you have a PC job or not.
correct.
Right. Now, Ashley, if you just remember what I just said, so it doesn't seem to matter. Okay, so it's the way of what you say. So you use the term infer, and that is an absolute no-no in the context of summarizing or visualizing data, just as it is. You cannot infer. You can only say that the data seems to suggest.
Okay.
Because the inference part comes only when you have statistically proven a certain mechanism. And we will look into these same exact data sets. That's why I introduced you to these data sets. We will look into these same exact data sets, and now we will apply statistical techniques on them, which will allow us to eventually say if really there is a difference between them. How confident are you that there is a certain level of difference between them? So that would be the next piece of the puzzle for us. Okay, and this is for everybody. When you are looking into visualization, always remember, you have not inferred anything yet. The inference comes only after you provide a probabilistic view of the puzzle and walk it through a statistical test. Okay, that is the next part of our class as we start looking into statistical testing. Right now, we are just summarizing, encapsulating what the data seems to look like. It still tells you a significant story. That's a starting point. You cannot infer from just the way the data behaves. And the reason being, and this is what we will learn in a sampling setup. So we talked about this in bits and pieces when we were discussing sample, right? So if I have a class of 20 students, okay, and I randomly choose 10 of those students, and that becomes my data set. And I do all kinds of visualization off of it. Because I'm truly choosing a random set of 10 students from 20, what is the guarantee that if I again randomly choose another 10 students, that my data set remains exactly the same? It's not, right? Every time you choose a random set of a sample, the numbers in that sample should change ideally. That's the whole idea of randomization. And so you have to tell yourself you're trying to analyze that single data set that you have randomly chosen and trying to infer from it. That's where a statistical technique comes in. Till a statistical technique is applied to it, you cannot infer back to the population. What you see here on this screen is very specific to this data set alone. And if this is a group of, I don't remember how many data points were there, but I could randomly choose an exact number of data points from people working at banks and have very different numbers. So the visualization here is very specific to the data set. It doesn't tell you anything beyond the data set. That is why you can't infer. You can only say that it feels that this is what is going to happen. Whether it actually happened or not, that is where a statistical technique will help you. Next one.
So finally, we have, similar to group one, we have education levels and average salary per education level, which we also broke down by gender, and then we have data, we have labels to show how many males and females are in each of those education levels. And similar to what group one said, it suggests that as education levels increase, that it's likely that average salaries increase along with it.
So for all of these, different representations, did you use gender as a filter?
Yes, gender was added as a color filter.
As a color filter. You could also show that as a filter. That way you could change by changing any one of those gender as male or female. You could see how those changes happen across all the other maps. Okay, so that's another way of interactive interface that you can create. While you have already done the hard work of using gender as a common filter across all of those outcomes, then you can also show that filter, and that way then communicate clearly the differences between them and how they change based off of a certain gender. But very nicely done. Good job.
Thank you.
Okay, if you can unselect, we'll go with the next team, which is Justia, Leslie, Nick Davis, Ping, and Ryan.
Yes, Dr. B, thank you for acknowledging that this is a learning curve, and we are trying to work within our realm of understanding.
No worries, no worries.
And so we did a Tableau story, 4 hours.
Very nice.
We're not, we didn't do like a slide for our 4 questions, but you can see that in the storyline as we go.
Good enough, good enough. It still solves the same purpose. That's the whole point.
Absolutely. And so our first was our overarching question is what factors impact salary in the banking industry. We'll go through, we actually looked at average salaries, and so for our first one, I can speak to, we wanted to look at does the data seem to present age in relation to average salary? And so what it seems to present here is that there is a positive association between age and average salary. It seems to present that there is some type of positive trend here with age and average salary.
Okay.
We did not get a chance to use filters. And so this, this is a really basic look at age and average salary.
I will provide one line of thought here, and this again applies to not this group per se, but to every single student in the class. These are all tactical, conceptual pieces. So you draw a line chart, okay, when you are continuing something that travels across time. Okay, so imagine that this is person A, Dr. B, at $33,000 when he was 23 years of age. Okay, and when Dr. B turned 25, it became 35,367. When he turned 30, it became 35. It's the same person traveling, then a line plot makes sense. This approach is the same. It should be a scatter plot.
Sure.
Because there are multiple people and you are trying to see all of those variables put together.
Absolutely.
Make sense?
Absolutely.
Go ahead.
And so as we go into the next one, again, making that scatter plot.
Go ahead. That's okay.
We do have the line. Our experience at the bank and average salary. We wanted to look at, does your experience within the company seem to present an increase in your average salary? And so again, we found this as a positive. I just lost my word.
Correlation.
And a positive trend.
So if I am between, if I am between 32 and 34 years, I should not join the bank.
Right.
Right? Okay.
Absolutely.
Okay.
And then I'll have one of my colleagues do the next one for us?
So I'll do the next one. So here we wanted to see if um, the average salary of people working outside the bank was actually higher or lower, and we kind of saw that depending on the number of experience outside of the bank, the salary was higher for people who had like a higher number of years of experience outside of the bank. And we didn't add any filters for this one. So that was a pretty like basic overview.
And then the fourth one, this is honestly, Dr. B, was kind of a filler slide. We were trying to see if age affected if you did a PC job or not. You know, based on what we
did age affect if you did a PC job or not?
Yes.
Okay.
And so, you know, we didn't know what the data would present, and so that's why we thought it would be interesting to see how that would flesh out. That this is the only one that's not related to average salary.
Gotcha.
And then,
so what does the data tell you?
It doesn't seem to present that there is any type of relationship between your age and if you work a PC job or not.
What, and this is average age is what is being captured there?
Yes.
Okay. Have you had a chance, I don't expect you to have read through all my videos in the learning module, but I think this kind of this specific question, and I would ask all the other teams to also try and address this question. Eventually, I think the fourth video, and I have sub videos too in the learning module, but the one that talks about, the last video, when we talk about outlier management, okay, I talk about box plots there. So when you eventually study box plots, this would be a great application of trying to see box plots of no PC job versus yes PC job.
Sure.
And by age, and you can see beyond just the average value into minimum age, maximum age, median, where that distribution is, the variability, the skewness, all of that can be captured. And give it a try and see if it can probably tell you a better story.
Sure. Thank you. And then as we look at our last one, we just wanted to see if years of education, and obviously, you know, one is some high school, two is some college classes. If the data, you know, if it seemed to show that the more education you had, the higher your average salary would be. And so we took a look at that and saw that, you know, there was a positive association, that there was a positive trend on that. And I didn't know if anyone else had anything to add as far as our storyline within our group. Okay.
Okay, good job.
Thank you.
Next team. Last one. David, Hunter, Isabel, Lauren, and Timothy. Who wants to share screen?
I think Timothy's got his Tableau.
Yeah, Timothy
Okay.
has it. Tableau.
Fantastic.
I guess I can start for our group. And our overall, our dashboard, our questions were very similar to group 2. So it's in relation to salary,
how different factors affect salary, looking at the group and using male versus female as a filter. So you can see that in the upper left that we can click on different, you can unclick and click male and female and see how it's different. Very similar in the upper left, we looked at the yes, no for PC jobs versus the salary. And you can see versus male, female. And so it looks like the data suggests that more females have the PC experience at least. So that's our first one that's slightly different, but kind of comparable to the other groups. I'll hand it off to our next set to do the experience versus the salary.
I can cover this one. Yeah. So then we went and we compared, experience to salary, and then we did like a trend line to kind of see just where the data was kind of taking us, and we could see an upwards trend. Males obviously get more a higher salary with more experience compared to the female, where it's kind of a plateau. And we obviously color coded this one too, and there's we did different plot points across for each salary.
And I had mentioned this to one of the teams, I don't remember now, but as you take your cursor to the trend line and you see those equations and the R-squared values, as you review my learning module videos, those will make a lot of more sense in terms of what explainability means. How would you want to objectively explain that first line, salary equals 1527 times current employment? What does that mean in the context? So in other words, for every extra year of employment, your salary increases by $1,527. That's basically what it's meaning. Okay, so those are some of the things that I discussed in my learning module. It'll give you more sense. So the R squared basically tells you that 78% of the change in, especially for males, 78% of the change in salary can be explained by their employment experience. And so that is quite a high value. And I suggest that those outlier points that you see on the top right, those are contributing to that higher level of explainability in the trend line. So a lot of these things, as you eventually review my learning module, come back to these trend lines and try to ask yourself, what does the trend equation mean in the context? Hopefully it will make more sense. Next.
Our age by salary doesn't look as pretty as it looked on the just the age tab. We were trying to differentiate like how the age affects the salary. So we've been doing it just by the males. So just looking at just by the male, we've been looking at how much the average 30-year-old male would draw. So for example, a person who's averaging at least 33 might be drawing about 49K or 49,000, while we see how a female who's about 37 years draws about $59,000. So that's what we started to understand from this data set, even though in comparison to PC job, yes or no, but an average female aged 37 years of age, she was drawing about $60,000. So that's how we've been comparing our data.
And then those numbers drop significantly as the number of years of experience increases.
Absolutely
right?
Correct, yes.
And if you recall, with one of the other teams, they presented this same data, but using a scatter plot, which probably in my feeling makes a better, so here you have to toggle between those to make a comparison, right?
Right.
The scatter plot allows you to see the comparison right in one set, especially if you can use gender as a color coding and differentiate between those genders. And then you can see that at the initial stage between the 30-35 years, actually females have a good run along with males compared to males. oftentimes better. But as you grow with experience, they kind of get lost, and that's where they flatten out their curve, as opposed to males who are consistently rising. And so, and that is, and this is the fun of visualizing. You look through multiple different ways of visualizing and come up with one that best tells the story.
Right.
Right?
And our fourth, the education, we just had it as a reference to see like who the salary range and what level of education they've had. So we've been comparing against the education and overall factors that have been affecting the PC job, whether it be the age
And
or whether.
right now it's only showing females, right? Can you click on both
Right.
genders and see? Okay.
So if for an average male aging 65 years of age, that person would be drawing about $74,000. So we would say, you would assume that he has obtained at least his graduate degree based on his education. But again, with his experience, we can't be certain that if he has had college, if he has obtained degree, or because of his age, he's drawing so much salary. So.
Well, this was very evident in the first team. If you recall, the first team actually showed you a bar chart that showed that the second level, which is finished some college course, okay? And you can see it right here too. If you arrange this bar in an order, in the ascending order, you will see that people with just high school education seem to have a higher average salary than those who have finished some college courses, right? Can you see the difference there? The way you have set this up, it's just the way you can rearrange that.
Okay.
Right? So you can rearrange that. There is a small tab, and you had to do this as part of your assignment to arrange that in a certain order. When you arrange that in an order, your 2 will be the first block from the left, and 1 will be the second one, which basically and this is old data. And I was telling Sarah's team when they were working on this that in the current scheme of things, it does not hold true. Education has a superlative value to salary. But there used to be once upon a time when people would join this industry right from high school and go up the ladder based off of their experience. And somebody with a high school degree with many more years of experience was valued more in the industry than somebody with a some college courses. But you could see that their average salary was less because they spent that part of their life on college education as opposed to actually working in the industry, and that came back to haunt them in this data set. So in summary, this is what I'll tell you guys. So I gave you a data set. You had to kind of read through the data set, read through the variables, and we have had our initial discussion a couple of weeks back. But in spite of that, to read through the data set, kind of come up with 4 or 5 broad areas that you would want to visualize, and then try and see how you can visualize that using a software that is only 7 days old in your learning artillery, and try to create a dashboard and try to create a storyline out of that, and all of that in 40 minutes or so. And that too in a team where everybody have their own opinions, and there's a clash oftentimes of opinions. And with all of that said and done, every team did fantastic. The idea here was to see how the storytelling happens, and hopefully from something as simple as this data set, you get the idea of storytelling, because that's the starting point. Because once this happens, then comes, okay, now that we have all of these feelings, right, that it seems that X and Y behave in a certain way. It looks like, and that Y and X, don't behave in a certain way. So it's time to now get into a territory where the feels like and looks like and seems like and all of that language can go down the drain, and we can infer with confidence that this is what is happening. So that's where the world of statistics actually helps us with the inference process. Okay? And as always, I'm over time. I'm sorry.